Welcome, students. I hope you're feeling pumped. This is the last new topic in machine learning and in this course that's going to be covered. It's Grid Search CV. Let's get started. Go ahead and open up the Grid Search CV starter code Colab notebook provided to you. Okay? When you do that, go to File, save a copy in Drive. Okay? When you click on that, you'll get a new copy. To make it your own, first rename it. Just call it Grid Search CV. And then go ahead and run the notebook. Okay, so you do runtime, run all. Now what we have in here is the simple bike rentals data set that we've seen before. And it's followed by a quick cross-validation. Okay. And again, we've had this code before too. Note that since this is using a regression, because we are using the standard count, trying to figure out how many bike rentals are there each day, that in fact it's we're using the scoring equals negative mean squared error here. Okay, so the lower the better. We get 901. Remember, the standard deviation is about 2000, so it's respectable, not bad. Okay, what is Grid Search CV? Well, Grid Search CV is actually it's a way that sklearn sets up for you to be able to fine-tune hyperparameters and compare them with ease. Okay, it takes a little bit of code, not too much. We'll go over it. But one important piece before we get rolling with grid search is that the splits and cross-validation, the splits in Grid Search CV are different. And so if you really want to compare scores properly, you want to actually use k-fold. Okay, you can do the splits separately. So let me show you how to do that. Let's do it together in this notebook. Okay, this is new code now. Go ahead and put it underneath the baseline score. So what we're going to do is from sklearn.model select. Actually, you could just, well, let's do it here. From sklearn.model selection, import k-fold. It's capital K, and then there you see it, k-fold. Okay, it's just a way of doing splits. Now look, let's do this. So write k-fold, lowercase, equals capital K-fold. Okay, and then inside we pick the number of splits. Let's go with 10 or 5 here. I don't know, you could even go with 8. Like it, I think anything between 5 and 10 is actually sufficient. Let's go with 10. And then this is where the very cool shuffle equals true comes into play. So it's going to be shuffled. So that way the dates are going to get mixed up, and hopefully it'll do a little better. So when you do that, go ahead and run that. So now when we go down to this XGB regressor, you've got the scoring metric, and then there's also a, I believe it's CV option, CV equals, and then you can write k-fold. So it's going to use this split setup above. And the reason why we're doing this is so that we can use the same split in the Grid Search CV, because then that allows you for real comparisons. Because if you're getting comparisons on different folds, test folds, it's a little trickier. So this is the proper way to do it. So run it again. And see what we get. Whoa! Look at that. That's way better. Wow. That's amazing. Just from, look at that, the shuffle, right? Because this is the thing about the dates, right? When the dates are in order, it's more problematic. You can tell this is my first time seeing that. That's a big increase, man, and a big, improvement. Wow. Okay, so this is great. That's going to be tough to top, even with Grid Search CV, which is what we're going to do now. We're going to see if we can top that. I'm impressed. You see, this also emphasizes the great importance of the folds, like what you're testing and training on. Okay, it matters. Shuffling is making a big difference here. Okay, so I want to put in a Grid Search CV, and let's do it. Okay, so first of all, what is the code for it? Well, we've got to find it, right? It's a library to import is also from sklearn.model selection. So from sklearn.model selection, import grid search CV. Okay. Now, grid search CV is kind of like its own model, but it takes in as inputs. I'll put this in a text cell for you. You could or could not try to write this down. So grid search CV is a machine learning model that takes as inputs a machine learning algorithm and basically a dictionary parameters to compare. And it also can include like with cross-validation, scoring, and fulls. So basically includes everything. But the real advantage is simply it's got the dictionary parameters to compare. I'm going to bold that. That's the thing, right? Before, when we were doing it, what does that mean? When we were checking and comparing all of the different, hey, what if I change it to this? What if I change it to this? Grid search CV can do that as one for you. Okay. My bold not stay in there. So basically when you click, it's their textiles are a little finicky. I really want this to be bolded. A dictionary to compare. There we go. Okay, so we import it first. Next, we need to pick our model and dictionary to check. Okay. So let's try the following. Let's say the model is the XGB regressor, and then we want to put in this reg squared error so those errors don't show up. Kind of annoying, but what are you going to do? Okay, they're trying to be helpful by putting out warnings. And then the parameters are what we're going to compare. Like, and you may want to, yeah, but like, how do I know like what parameters to pick? Okay, here's what I want you to do. I want you to go to a new Google search, and I want you to type in name of my book, Hands-on Gradient Boosting with XGBoost and Scikit-learn GitHub. Okay, type that in. So this is the book that I wrote. It's on XGBoost, and it brings up the GitHub page, which is all code. This is good coding reference for you guys if you want to try to bring your machine learning to the next level. And in chapter 6, there are hyperparameters. Okay, that's what the topic is. That's what we're doing right now. These are the parameters that you can change. And it's got a nice list and ranges that you can check. So if you just scroll down, a lot of this code you don't need, but see, like, here are some different parameters that we can like check and test. So look at like max depth. Okay. Let's copy that in or write it. And when I go back to my notebook, so I've got params, I'm setting it equal to a dictionary. And the dictionary includes max depth. And we'll just do one more. Okay, you could only do one. But let's try it with in-estimators. It'll be a little fun. Now, in-estimators is the number of trees. Okay, max depth is the length of the tree. And in-estimators is the number of trees. So by default, it's actually 100. So changing max depth will include it. Is less better or more? Okay, I'll just leave it at those values. Now, in grid search, okay, you need to know what this is going to do. Close the dictionary. It's going to check all possible combinations. So I've got 1, 2, 3, 4, 5 here, and 1, 2, 3, 4 here. That's 20, okay? So grid search in itself is going to check 20 different combinations because you just multiply to figure out that number. And it's going to return the best combination with the right code, okay? Note that it's cross-validation though, so it's times 5. So it's actually 100. So it's going to run 100 machine learning models, okay? Now this data set is 731 rows, so it shouldn't take too long. But you have to be really careful with Grid Search CV because you don't want to take forever. There's a randomized search CV that you can use that can include in a bonus lecture that can be helpful as well. All right, so now we set up the grid search. Okay, so I'll call it grid. We should call it like reg for its meaning it's a regression model, and it's grid search CV. And then inside I want the model, the parameters. We've got to use the same scoring metric with regression. So we can use negative mean squared error. I want to get the same splits, which are k-fold. I think that's still just CV. And then let's check that. Now, well, you know what? Let's go ahead and put the rest of it in because when we run that, nothing's going to happen. Okay. What we need to do is we need to figure out how to get it to actually show stuff, right? Because how do we get to how do we get the score? Well, the first thing you want are the best parameters, okay? And actually before that, so that's actually initializing model. Okay, let's get all the key code in here. Initialize model. Now here we're going to do fit the model. Okay, so this is where it's going to take time. Gridreg.fit. See how it's just like a machine learning model? You initialize it, then you fit it on X and Y. And again, we don't need, it does cross-validation for us, so we don't need to split the data. Okay, so when it does that, by the way, it finds the best parameters and scores. We just have to extract them. So we can like show best parameters with, it's gridreg dot best underscore params. And I think it has a additional underscore. And then we also want to know what the score is, right? So we do grid similar gridreg dot best underscore score. Oh wait, we've got to fix the score. Note that these do not use parentheses because they're not really functions. They've already been found. We just have to extract them. So this is the scores. It's negative MSE. Whatever. I'm just going to write scores. It's negative mean squared error, right? And then what you want to do is you want the the RMSE. So the RMSE equals the negative scores to the 0.5 power, right? Let's just call this one. We got we want to be sure we show them both. So I'm going to call this best params equals this, and then best score equals this. Why? Simply so that we can print them out. That's all. So you want to print the best parameters. You want to print the best score. Okay, it's a lot of code. Now, hopefully it won't. Look, it's going to take time to run here. So there's an error after that. We'll be sure not to run it all again. Okay. I was wondering. I was going to say, anybody see any errors here? But you guys aren't live with me. It looks about right. Gridreg fit. Okay, press shift enter. Yeah, I got an error. Grid search is not defined. Why? Because I did not run this first. And that's also why I mentioned about sometimes it's nice to have all your code together. So what I'm going to do here is put it up top. And then this whole cell block can work. Now I can call this. Oh, look at that. Look at the color coding notice too. Print best parameters and score. Try it again. And it's working. You can see this green arrow, by the way, shows you what it's working on. right? It's going to do 100 machine learning models here. So it takes time, right? Because even with 700 rows, right? Plus 10 columns, that's 7,000 plus 100. So it's doing like 7 million data points. Okay. So it's going to take a little time here. This is what I mean about grid search. Sometimes what I do is I only write one of those. Score is not defined. Well, look, it gave us the, look, before I'm not going to run it again. I should have written scores. It did go through the whole code. It did give us a best parameter max depth of 2 and estimator equals 400. And so if I just want to run that line, I can go to a new coding cell. So I don't have to run the whole thing again. And it didn't compute correctly because it gave a negative score. Oh, because it's RMSE, not scores. Excuse me. See, it's hard. See what I mean? Like it's hard to tell. How good is that? I don't know. What's the RMSE? Get in the right units. 617, man, that's really good. Up from 632. Not a huge improvement, but an improvement. Okay. So that is an introduction to Grid Search CV. For some of you, that may be enough. You don't have to use it. You can move on. For those of you who want to dig a little deeper, I'm going to do an additional lecture that puts this into a function, looks at a couple more parameters, and also looks into a randomized search CV. Okay. Great job, everyone. Oh, and I'm going to run this again because I like clean code top to bottom. Have a good one.